where I currently live because I live in a dorm. So so what we did, as I said, we needed to analyze data. The data got from the Winkler source database and the Indiana estimate. And also we needed to do some simulation after we process the data and determine the dominant characteristic of the wind. And then we use the input of those into the simulation work. So this is the website that I got, the Winkler source database. It's owned by the government and the Indiana National owned by the Berkeley University. So this website, those websites provide us like the historical wind data measured by an hourly. So we process the data and then we visualize the dominant characteristic by some of the statistical method, which was the Weibull distribution, where it has two parameters, K and C. And also we use a label distribution. Each distribution will have some probability density function, and we visualize the dominant characteristic. We automate those calculations by the Excel and some Python. We automate all of them. So this is the thing I found, like for example, like ear data wind. Like we found the average speed, we found the average direction, we know peak probability density as well. And also most important thing is definitely dominant wind speed. We definitely did the same thing to summer and spring, and we did like seasonally and the yearly. Also we know the wind data from each month as well. So at this point we had pretty enough information of wind to jump into the CFA model. So we set up the CFA modeling first here. We set up the domain. When we set up H as a ridge height, we need to make some domain as a 5H upstream and a 15H downstream, and a 5H the top boundary as well, so that we can have some enough space to capture the wind distribution and the circulation, like the wind before hitting the greenhouse and after hitting the greenhouse. Also, we set up some of the like CP value, which is pressure coefficient, which is a major tool to evaluate the wind pressure and identify like which area is got stressful from the wind pressure. And also we definitely set up the meshing. We use some local meshing of like something like 1 meter and outside, but we use a much defined meshing near the greenhouse so that we can capture how they interact with the wind and the greenhouse surface. So we definitely also got some the CP distribution, and the more likely we get a positive the pressure definitely on the left wall and the wind wall. And the more likely after hitting the greenhouse we had the negative value that creates some suction. And also this point is definitely has a lot of the negative pressure, also like creating a lot of suction. So also we analyze a little bit more detail, like each side of the greenhouse, like on the wall and roof and roof. I just only bring some one graph, but we also analyze each greenhouse, the CP distribution on each wall by using CP versus curve and graph. And we use like for each geometric condition of greenhouse, we use like different boundary condition, like we use summer wind condition, spring, fall, and winter and yearly for one geometric condition. So also I changed the geometric condition. So what I wanted to do is by alternately changing the geometric condition and the boundary condition, I wanted to see like how the lizard will be going. So for example, like this is the example that like, for example, like 20 degree and the 30 degree. If you look at a 30 degree here, the greenhouse structure has a much more negative CP value after they hitting the wall. Like below is very negative, it's creating suction and uplifting the force, which is very stressful on the greenhouse. And also you can tell at the top pretty hard, and also very stressful in here. And now we look at the 20th degree, and it's a little bit the better negative value in here. Of course, it's definitely stressful in there. So also another thing is we change the loop as well, the loop type. This thing has a little bit more smooth distribution, but the problem is they had a very strong suction here, which is almost like minus 38, very stressful. So from by comparing all of those, we could tell the best greenhouse structure, the fit on the Hammond, Indiana wind condition. I could say the lake height out of 4.96 meter, and the slope of 20 degree, and a wall height of 3.5, and the width of 8. So maybe I can tell this greenhouse structure and geometric condition the best structure of the Hammond, Indiana wind condition. So definitely we had a lot of limitation. We just only conduct 2D, and I wish I had a little more time. And it's kind of my mistake. I spent too much time on wind data analysis, and I didn't balance as well. I didn't put too much time, enough time on the CFA moment. So we just dealt with 2D, and definitely I want to in the future. I definitely want to put more better parameters like the humanity, or I can change some of the geometry condition, like putting some ventilation or like the greenhouse grouping, like just not only one single span greenhouse. We can like make some grouping greenhouse. It's going to make some like shielded bed or something. It's going to be very different. So I definitely want to continue on this work, and definitely I very appreciate the professor good at it, because during that time I had a small issue on my ability to participate in the program, just like Sunshine, because we was an international student. But like Professor Good at I very appreciate he gave me a very good opportunity to participate, and also I very appreciate to Professor Wang. She's like my Chinese mother, so I very appreciate it, and I very enjoy the program, especially with you guys. I love a lot of this. Thank you so much.
Any questions for Hyobeen?
So, what would you say is like the hardest aspect of your research for you to do?
For me,
Yeah.
like I was a little bit underestimating the amount of time that I need to put on CFA model. I was spending pretty lot of time on wind data analysis, because I was underestimating. I thought it was going to be pretty quick, but I shouldn't. Yeah, so it was the hardest point, because it took me pretty lot of time, and I thought, I need to start from the 2D because the time is running out. And I think that was the most toughest one.
Thanks.
Any other questions, comments for Hyobeen?
How did you feel that your background in statistics helped you with this project?
Yeah, I mean, I'm very, very happy because Professor Wang provided me 3 different topics. One was them, and one was like the air turbine, and the one was the greenhouse structure about the analysis. And this topic was requiring me more statistical knowledge. So even though she said it's going to be most comprehensive and more tough, but I decided to jump in because I know I want to build up my knowledge, and yeah, so I very feel good. I do not see any great regret to choosing this topic. I've been pretty much good.
Thank you. So we'll do one more presentation and take a 5-minute break.